Hello, my name is Navneet Kataria and I'm the Product Marketing Engineer for Vector Network Analyzers. Today, we are going to talk on the latest introduction of one of the options called as UFX, option 21, which we have recently launched with Vector Star. This UFX is called as Universal Fixer Extraction. And for doing the demonstration today, I need a vector network analyzer. So this one is a MS4644B, a 40 gigahertz vector network analyzer. Apart from that, I also need calibration components, as you can see from the top. And then these components are coming from the calibration kit that we have, 3652A. So these are the female standards, those are the male standards, and we also be using some of the adapters. Apart from that, I'm using semi-rigid cables, and this one is going to be my DUT. Now, talking about the universal fixer extractions, so it's basically a de-embedding tool, and Anritsu already has this option 21 in the kitty, and we have been doing a lot of de-embedding techniques already which are available on the Vector Star, and I'll just show you how they actually work. So when we go onto the calibration and the de-embedding tools, we have something called as two-port network extraction, and we already have 7 kind of extractions, network extraction techniques already available for various kind of setups and various kind of DUTs which are there. But all these 7 standards in today's world, they need full set of calibration standards. So as you can see, from type A through type G, you can do a lot of network extractions. However, in today's world, and basically for the signal integrity kind of applications and some other applications, wherein you have a device and known standards or the full set of standards are not available for doing the de-embedding. Now that is gaining a lot of tractions, and it's basically on wafers and in signal integrity kind of applications wherein the standards are not available. So I can consider this particular cable to be like an adapter, but I don't have full set of calibration standards to de-embed this portion. So this UFX option 21, and we'll today be talking only about type B 2-tier calibration with flexible standards, as I mentioned, because we don't have all the standards available, or there are some other problems that occur. So today's video will basically be on the 2-tier calibration with flex standards, when we will consider this as the DUT, and we'll try to show you how you can de-embed this particular cable. It could be an adapter, it could be a probe, and because you don't have known standards available, you make use of some flex standards, or maybe you have a characterized file already of this guy, so you can de-embed that as well. So it depends. It will be a combination of all the things. So what we'll do today is, because you don't want me to see doing the calibration and all, so I've already saved the calibration. I will be doing it for one port at this moment, and later on I'll show you some more de-embedding techniques in which we will apply 2 more kind of fixtures to these 2 cables, and then we'll have a DUT in the middle, and we would want to de-embed these 2 fixtures from our network. But moving on, I wanted to do this demonstration first today with you, that how to get rid of these adapters or cables or whatever it is. It could be anything. So I'm assuming this to be my DUT. I'll be doing a 1-port calibration, and let's get going. So on the VNA, what you need to do is, I'm just recalling my calibration first. I'll recall a 1-port calibration, so you'll see that the calibration is fully done, and I'm on the S11. So it looks pretty good to me. So what we need to do now is, let's attach this cable to our port number 1. after attaching this cable, what we'll do is we'll just put a short at the end of the cable. So this is basically going to give me the loss of the cable, and that is how you measure the loss of the cable, by putting a reflect standard. And then I go to scale and I do an auto scaling. So here on this graph on the VNA of S11 reflection log mag, what you will see is that this depicts the loss of the cable, and at the end you will see a huge mismatch because this port of the cable has not been calibrated, and that is why it's leading to a lot of source match, right? So this is how it looks. So let's assume that we do not have any calibration standards like open, short, and load available to do a calibration at this port, but we somehow want to get rid of this length and the de-embedding, and we want to do the de-embedding. So what we'll do here is, again, we go to calibration, we go onto the de-embedding tools, we click on 2-port networks, and we go to 2-tier calibration with flex standards. And what you can see on the display of the VNA is that you have done the calibration at these two or this point, which is A, and then you have a question mark at the end of this cable because we don't have any known standards available for doing the calibration. So it's pretty straightforward. We go on to the 2-tier calibration with flex standards, and now there's one more window which opens up in front of you. Now you can select port 1, yes, because we are at port 1 and this is what we want to do. The number of standards here, our GUI gives you this freedom that how many standards do you have are available. It could be 1, which could be just open, it could be short, open and short, and it could be open, short, and load. It depends, you know. So right now we'll assume that we do not have anything. We just say, okay, I have one standard which is the open air, so I'm going to leave the end of the cable as it is. I just say open, and I have something called as a quick extract. Now this quick extract checkbox gives you the freedom that you don't have to separately store the file as a S1P or a S2P file in the as a separate place on the vector network analyzer. If I do quick extract, it's going to store this file into the internal memory and then automatically de-embed from the entire measurement system. So what we'll do is we'll check that thing, quick extract, and now we just leave this thing open, although a lot of radiation will be happening here. So we just click measure, and right now it's just measuring the open. And now I say, okay, perform a network extraction. Now it says that the generalized B network extraction has been done and it's completed. Now it's asking for us to do the de-embed. And I do the de-embed, I click apply, and you'll see that this has really been de-embedded, and you can see it's like a straight zero line on the vector network analyzer. However, now what happens is if I do a scaling of this thing and I do an auto scale, you'll see that because it's radiating, you know, and that's why it's not stable. So what I'm gonna do is I'm gonna again go back to the calibration, and this time what I'll do is I take a known standard, which is this open, this is the open. So what we'll do is we'll go back to the calibration, to the de-embedding tools, 2-port networks, and we select the 2-tier calibration with flex standards, port 1, number of standards is still 1 because I'm just using this one open. I select open, and if you know the length or the offset length of this open, that's even better. In our case, we already know it, so I just input that number. I connect this shielded open at the end, so that means now I have one known standard that I want to use, and then just by this one known standard, I can actually do the de-embedding. And I go and press measure. It measures right at the end of the shielded open, and I perform a network extraction, and I apply. And now you'll see if I again go back to scale, I do an auto scaling, this has stabilized a lot, right? So you can see it, but but the problem is that it has been done but only with one standard. Now I'll tell you the advantage of using more standards to it. So if I disconnect this open and I connect a short to it. Now short is an extreme example because it's like 180 degrees phase shift from the open. Let's do that and let's see what happens. You see that there's a huge mismatch happening when I connected the short. So I just go to scale and again do an auto scaling, and this is like huge match. If I disconnect the short again and I connect the open back, now because open is already taken care of and in the known standards, you'll see that the mismatch is not that bad with the open, and you can see a straight line. But with the short, which is again an extreme example of 180 degrees phase shift, I just connect the short again and see what happens here. Yeah, so there's lots of mismatch, and you can see that the variations are huge. So what I'm going to do is I'm going to store this into the memory so that when I do the second standard calibration, so right now it's just only one standard, and I just connected a short, and I can see that the mismatch is pretty much there, but it's not that bad. It's like still within the range of 0.5. Now what I'll do is I'll go back to calibration, again the de-embedding tools. I go back to 2-port networks. I perform a 2-tier calibration with again flex standards, and this time on port 1, instead of only one standard, I select 2 standards, which is one is the open and the other is the short. If you know the length of the short, good. In our case, we know it, so we are going to do that. Now I disconnect the short, I connect the open again, when I connect the open, and I just have to say measure. We can do the measure with the open first. So these are just with 2 standards. You can actually select 3 if you have, but in wafer kind of applications, and when you have fixtures for signal integrity, you always don't have 3 known standards. You have some standards of which you know the offset length, so you can input that as well. So that is the advantage of this feature. So now we have connected the short, which is the standard 2. I go on to measure the short, and yeah, so now we are done. So we perform the network extraction. I click on perform network extraction. I say yes, and I de-embed, and now you'll see that this guy is again like flat. So that means now you have taken care of the short as well. And now just with these 2 standards, you have actually de-embedded this particular adapter or the fixture, or it could be the probe. Just to cross verify, let's go back and now display the data and memory. So you can see this is the improvement that we have got when we were just connecting the short with only one known standard, but now we have 2 known standards, and this is the short. I go back to open because this is a question which comes really hard on me, that now can you connect the open and see if things are still fine with the open. So let me connect the open. I connect the open, and you have a flat 0 line for the open as well. So that means without much of a pain, and only even with one standard, in fact without even one standard, when you were just doing a normal open-ended cable, assuming that it's an open and we don't know about it, you can still de-embed these kind of fixtures to a very large extent. But as you keep on adding the known standards, it helps a lot. Sometimes what happens is that people do not have any of the standards available, but they have a S1P file of this guy available with them. So using this GUI and this UFX option, you can actually not connect any known standards, just put in the S1P file of this guy, and you can directly de-embed. So this is the advantage of UFX. I hope you liked the video. In case you want to know more about all the other 7 type of de-embedding techniques that we have, and I'm telling you, it's very, very useful. If you want to have more videos coming from us for all the 7 techniques, let us know and we'll do those kind of videos for you. Thank you for watching.